Okay. We're live on YouTube. You didn't know that. Okay, if you're on YouTube, we'll start in a couple of minutes. So make sure to tell me that you can hear okay. So can you hear me on the YouTube? Well, if one of you replies, that's probably good enough. Okay, so they can hear on YouTube. Jacob Morgan, Alexander Perez, Richard Renlees, Michaela Shook, Gerardo Silva, Marcus Thompson, Ernesto Vega, Chloe Wilbur, Taylor Williams, Zach Winters. So, anybody from Group A here? Oh, that's right. Isabella? Anybody else? Did I call everyone? Okay. Alexander? Gerardo?
Yeah.
Okay. Anybody else? Okay, well, it's 8 o'clock. We will continue in section 1.3. We haven't covered that yet. But first, I just want to put the schedule on the overhead. So yesterday we covered 2.1a on solving linear equations in one variable, 2.1a. Today 1.3 is the section on fractions. This is part of the remedial material that we're going to cover. Tomorrow 2.1b is more solving linear equations in one variable, but in 2.1b we'll encounter fractions and decimal numbers. And then on Thursday we will cover section 2.3, and on Friday section 2.5. So the Newton assignments will become due. Let's see, the first one is due tomorrow. And then the due dates for the Newton assignments will come pretty steadily after that. So you'll want to make sure that you get started with the Newton assignments and then keep up with those. It's not that easy to catch up if you fall behind. Okay, let's take a look at section 1.3 on fractions. Everyone loves fractions. Okay, a fraction is a way to represent parts of a whole. For example, the fraction 3/4 or 3/4, that represents 3 of 4 equal parts. the number on top is called the numerator. So in this fraction, 3 over 4, the numerator is 3, and the denominator is 4. That's the number on the bottom. You can represent fractions visually. So if I have 4 squares that are equal in size, and if I shade one of those squares, well, we can use fractions to describe what we're looking at. We could say 3/4 of the squares are not shaded. Three out of 4 are not shaded. What about the shaded ones? Well, 1 out of 4 is shaded, so we could say 1/4 of the squares. Well, since we just have one square that's shaded, we could just use the word is. 1/4 of the squares is shaded. Okay, but 1/4 or 3/4 for that matter, that can represent quantities for a lot more squares than just 4 squares. This just indicates that 3 out of every 4 squares are not shaded, and 1 out of every 4 squares are shaded. Okay, the next thing is the equivalence property. So if A, B, and C are numbers where B is not equal to 0 and C is not equal to 0, then the fraction A over B is equal to A times C over B times C. So let's list a few fractions that are equivalent to the fraction 3/4. There are infinitely many to choose from, but we just want to list a few of them since we don't have that much time to list infinitely many. So one way to find a fraction that's equivalent to this one is just to multiply the fraction 3/4 times 1 in any form that you like. So if I want to multiply 3/4 by 1 in the form 5 divided by 5, we all agree that 5 divided by 5 is 1. And if you multiply a number by 1, you just get a number that's equivalent to that number in value. And then when you multiply fractions, you just multiply the numerators. 3 times 5 is 15. And in the denominator, 4 times 5 is 20. So the fraction 15/20 is equivalent to the fraction 3/4. Yeah, so this is remedial material. This might all make sense to you, but we want to make sure that we cover fractions. Well, we could multiply 3/4 times 1 in the form -2 divided by -2. -2 divided by -2 is 1. And this time the equivalent fraction that we get is -6 over -8. Okay, that's just a couple of equivalent fractions to 3/4. Hey, if a fraction a over b is in lowest terms if the greatest common factor of a and b is 1. So by greatest common factor, we mean, well, if the fraction is a real fraction, meaning that the numerator is an integer and the denominator is a non-zero integer. So the integers, just to remind you, the positive integers are 1, 2, 3, 4, 5, and so on. The negative integers are -1, -2, -3, and so on. 0 is an integer. But whenever we have a fraction, we want to make sure that the denominator is never 0. 0 in the denominator is not permitted because division by 0 is undefined. Okay, so if the greatest common factor of the numerator and denominator is 1, then the fraction is in lowest terms. So let's go back up here, 3/4. The integer factors of 3, I'll just say the positive integer factors of 3 are 1 and 3. What are the positive integer factors of 4? When we use the word factor or factors, we're describing numbers that are multiplied together. So two positive factors that we could multiply to get 4 are 1 and 4. 1 times 4 is 4. So 1 and 4 are positive factors of 4. We can also multiply 2 times 2 to get 4. So 2 is also a factor of 4. So factors of 4 are 1, 2, and 4. We don't need to list 2 more than once. Okay, so the common factors of 3 and 4 are just 1. 1 is a factor of each one. 1 is a factor of every number. Okay, so 3/4 is in lowest terms because the greatest common factor of 3 and 4 is 1. Does that make sense? Okay, so here are some fractions, and we want to write the following fractions in lowest terms. One strategy for doing that is to find all of the factors of the numerator and then find all of the factors of the denominator. If we use prime factors in a more basic math class, you might have learned how to find the prime factorizations of integers. So you can think of 210 as 2 times 105. 2 is a prime number. Remember what a prime number is? A prime number is a positive integer greater than 1 whose only positive integer factors are 1 and itself. So 2 is a prime number because 2 and 1 are the only positive integer factors of 2, 1 and itself. 105 is not a prime number, but 5 is a factor of 105. And 5 is a prime number because 1 and 5 are the only integer factors of 5. So in the next step in this prime factorization tree, I'll bring this 2 down, and then 5 goes into 105 21 times. So I'll write 5 times 21. So 2 and 5 are prime numbers. 21 is not a prime number. So we just have one more step. 21 is 3 times 7. And both 3 and 7 are prime numbers. Okay, I'm going to use more space than I have. So what I'll do is I'll pull up another sheet of paper if necessary. So the paper is off the screen. Okay, so is that better? Looks a little better. Sorry about that. Okay, so for the numerator, the prime factorization of 210 is 2 times 5 times 3 times 7. And then let's do the same sort of thing for 110. 2 is a prime number, so 2 times 55 is equal to 110. A prime factor of 55 is 5. 5 times 11. And 5 and 11 are prime factors. Okay, so on another piece of paper, I'm going to write this. So the prime factors of 210, I'll put them in ascending order, 2 times 3 times 5 times 7. And the prime factors of 110 are 2 times 5 times 11. Okay, so this is the fraction that we were just looking at. And then we look for common factors in the numerator and denominator that cancel each other out. 2 divided by 2 is 1, so those cancel each other out. And then 5 divided by 5 is 1. And we don't get any more cancellations than that, so in lowest terms, we get in the numerator 3 times 7 is 21, and in the denominator, we get 11. Okay, that's one strategy for writing fractions in lowest terms. So maybe we can do the next one a little bit faster. So let's just think about what we're looking at here. Negative 30 over 105. Let's do part of this mentally or in our heads. So 2 goes into 30 15 times. So I'll write down 2 because that's a prime number. And then 15, 3 times 5 is 15. So in the numerator, I'm replacing 30 with 2 times 3 times 5. You can verify that 2 times 3 times 5 is 30, and 2, 3, and 5 are prime numbers. In the denominator, 105, 5 goes into 105 21 times. 5 is a prime number. And then 21 is 3 times 7. And then, now that both the numerator and denominator are completely prime factored, we look for common factors that cancel. 3 divided by 3 is 1, and 5 divided by 5 is 1. And so in lowest terms, we get negative 2/7. Okay, one more. This one has variables, 42 times x times y divided by 18x. So in the numerator, let's write down the prime factorization of 42. 2 goes into 42 21 times, so I write down the factor 2. We keep seeing 21 over and over again. 2 times 21, 21 is 3 times 7. And then x times y. And then in the denominator, 18, 2 times 9 is 18, and 9 is 3 times 3. And we have a factor of x in the denominator also. Okay, so we cancel the common factors. 2 divided by 2, 3 divided by 3, x divided by x. And then we write down what's left. In the numerator, 7 times y. And in the denominator, 3. Okay, the next topic is multiplication with fractions, multiplied fractions. Okay, so we've already actually multiplied fractions today, but here's a formal definition. If A, B, C, and D are numbers where B does not equal 0 and D does not equal 0, then A over B times C over D is A times C divided by B times D. So whenever you multiply two fractions, in the numerator of the product is just the product of the numerators, A times C. And in the denominator is the product of the denominators, B times D. Okay, so we'll multiply some fractions and then write the products in lowest terms. So there's a hard way and an easy way to do this. The hard way, if you just multiply the fractions, so we get negative, and then in the numerator, 3 times 4 is 12. In the denominator, 8 times 15 is 120. And then write the fraction in lowest terms. Well, this one isn't too bad. Notice that 12 is 1 times 12, and 120 is 10 times 12, and 12 divided by 12 is 1. And so the fraction in lowest terms is negative 1/10. Notice that I didn't write down the complete prime factorizations. You can, if you want to write the complete prime factorizations, you can. But it's not necessary if you see common factors that will cancel each other out. Okay, so I call that the hard way to do it. Before you do any multiplying, you can look for cancellations ahead of time. So since we're just multiplying two fractions, this numerator 3 and this denominator 15 have 3 as a common factor. So 3 goes into 3 once, and 3 goes into 15 5 times. And then we look at the other denominator and numerator, 8 and 4. 4 goes into 4 once, and 4 goes into 8 twice. So now we can just multiply, I'll put in one more step. We can multiply negative 1/2 times 1/5, and we get negative 1 times 1 is 1, and in the denominator, 2 times 5 is 10. So I get negative 1/10, just like we did prior to that. Okay. Yeah, sometimes the hard way to do it is pretty hard. It wasn't really too bad in that first example. But this next one, if you do it the hard way, negative 9/10 times 25/33, well, let's see, 9 times 25 is, so I have negative 225 in the numerator. 10 times 33 is 330. And then we can find common factors from the numerator and denominator that cancel each other out. So this could take a few seconds. It will take fewer seconds if we look for cancellations before we multiply. So since we're multiplying two fractions, notice that the numerator 9 and the denominator 33. 3 goes into 9 3 times. 3 goes into 33 11 times. Then we compare the denominator 10 and the numerator 25. 5 is a factor of each. 5 goes into 10 2 times. 5 goes into 25 5 times. And our fraction is negative because we're multiplying a negative number times a positive number. So we get negative 3 times 5 in the numerator is 15. And in the denominator, 2 times 11 is 22. So negative 15 over 22. Okay, we do have more examples to do. I think what I'll do, though, is we'll look at division. We'll do a couple of problems with division, and then we'll have some problems where we add and subtract fractions. And then if there's time left over, we'll come back and go through the cycle again. Okay, so for now, let's look at dividing fractions. Okay, here's a definition. If A, B, C, and D are numbers where B is not equal to 0, C is not equal to 0, and D is not equal to 0, then the fraction A over B divided by the fraction C over D can be converted to multiplication. It's A over B times D over C. So notice that D over C is the reciprocal of C over D. So every division is equivalent to some multiplication and vice versa. So this is a really important concept. If you've never understood this one, it's really important that you do. Division by a fraction is equivalent to multiplying by the reciprocal of that fraction. Notice the fraction on the left stays the same. A over B divided by C over D is equal to A over B times the reciprocal of C over D. That is A over B times D over C. See what I mean? Okay, so in general, even when we aren't working with fractions, in general, multiplication is simpler than division, but especially so with fractions. So we can always convert division to multiplication. So the fraction 5/18 divided by the fraction negative 15/24, we leave the fraction on the left the same, 15 or 5 over 18, I mean. we're changing from division to multiplication, and so we write the reciprocal of negative 15 over 24. So we get negative 24 over 15. And now we can just multiply. Now we do what we did on the previous page. So we're getting practice multiplying in these division problems. So let's do it the easy way. First note, I'm multiplying a positive number times a negative number, so I know that the result has to be negative. A positive times a negative is a negative. Then let's compare the numerator 5 with the denominator 15. 5 goes into 5 once. 5 goes into 15 3 times. Now let's look at 18 and negative 24. In the numerator, negative 24, the denominator 18. Well, the greatest common factor of 18 and 24 is 6. If you don't notice that 6 is the greatest common factor, if you find a common factor like 2, you can whittle it down piece by piece. It will just take a little bit longer. If you see what I mean. 2 goes into 18 9 times, 2 goes into 24 12 times. And then you'll notice, 9 and 12, 3 goes into 9 and 3 goes into 12. Right, so you can get to the end result piece by piece. So don't worry about it if you don't automatically see what the greatest common factor is. But the greatest common factor of 18 and 24 is 6. 6 goes into 18 3 times. 6 goes into 24 4 times. And a positive, so what we have, I'll write down a little more detail. We have, it's a positive times a negative, so it's going to be negative and then 1/3 times 4/3. And then we get negative 4/9 for the result on that one. Okay, let's do the next one. This fraction involves variables. 12x over 25 divided by 18y over 35. So we're going to convert it to multiplication. The fraction on the left stays the same, so 12x over 25 multiplied by the reciprocal of this fraction on the right. So the reciprocal is 35 over 18y. And then before multiplying, let's look for common factors that cancel each other. So in this numerator, we have 12x. In this denominator, we have 18y. 6 is a common factor of 12 and 18. 6 goes into 12 twice. 6 goes into 18 3 times. And then look at the other pair of the denominator and numerator, 25 and 35. 5 goes into 25 5 times. 5 goes into 35 7 times. So in the next step, let's write 2x, 2 times x over 5 times 7 over y. And then we just multiply these fractions. 2x times 7, we write that as 14x, 14 times x. And in the denominator, 5 times y is 5y. Okay, there's a number of different ways that you encounter division, adding to the confusion sometimes, but with practice, you'll be able to do this. So this one, negative 15 divided by negative 5/3. You can think of negative 15 as negative 15 over 1. And then if we convert from division to multiplication, we put multiplication, and then we write the reciprocal of negative 5/3, which is negative 3/5. Okay, so this time we're multiplying a negative number times a negative number, so the result will be positive.
On the previous problem, should it be 5 times 3 1? To get 15 1 on the denominator?
Could you write it down? Could you write your question on paper and bring it to me? Okay, so let's go ahead. A negative times a negative is a positive. Why don't we take care of that right now? So we have 15 over 1 times 3 over 5. And then we notice that 5 goes into 5 once, and 5 goes into 15 3 times. And then 3 over 1 times 3 over 1 3 over 1 times 3 over 1 is 9 over 1. And then 9 over 1 is normally written as 9. Okay, it was pointed out that I made a mistake in this problem up here. It should be 3y, 3 times y. And then the numerator is okay. 2x times 7 is 14x, and then 5 times 3y is 15y. So it was disastrous, but it was pretty easy to fix. Thank you. Yeah, so some people on YouTube noticed that it was wrong also. Okay, let's move on. Let's do this one. We have negative 9/16 divided by 33/40. So you could write it this way. You could write it as negative 9/16 divided by 33/40, and then convert it to multiplication. So we could write negative 9/16 times the reciprocal, which is 40 over 33. And then we can look for common factors that will cancel from the numerator and denominator. We're comparing 16 and 40. 8 is a factor of 16 and 40. 8 goes into 16 twice. 8 goes into 40 5 times. And then we compare negative 9, or just compare 9 with 33. We know the product has to be negative. So 3 goes into 9 3 times, and 3 goes into 3 goes into a 33 11 times. And the result is negative, and in the numerator, 3 times 5 is 15. And in the denominator, 2 times 11 is 22. Okay, let's move on to adding and subtracting fractions.
So I had a question. In that last problem, is just the 9 negative, or is it the whole fraction?
This is an entire number that is negative. You could think of negative 9 over 16 as negative 9/16. So it's a negative number. So yeah, the fractions, if you have a negative number in the numerator, so equivalent ways to write negative fractions, like that particular fraction that you asked about has negative 9 in the numerator and positive 16 in the denominator. That's equivalent to writing negative 9/16. So the number's negative. A less conventional way is to write it as positive 9 over negative 16. And especially when you're working in software like Newton, often I'm pretty sure that they don't like, the computer doesn't like negative numbers in the denominator. So put the negative number in the numerator, or just make the negative sign even with the fraction bar. All right, let's talk about adding and subtracting fractions for a few minutes. Okay, if A, B, and C are numbers where C does not equal 0, then you can only add and subtract fractions if the denominators are the same. So A over C plus B over C equals A plus B over C. The denominator remains C, and you just add the numerators, A plus B. And also with subtraction, A over C minus B over C, the denominator is C, and then in the numerator, it's A minus B. Okay, so in this first example, the denominators are not the same, so we have to do preliminary work before we add these fractions. So we want to find a common multiple of the denominators. The multiples of 12 are 12 times 1, 12 times 2, 12 times 3, and so on. The multiples of 8 well, 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24. We could keep going, but we found a common multiple, 24. So we can multiply each of those two fractions by 1 in special forms so that the equivalent fraction has a denominator of 24. So 5/12, well, let's see. What would I have to multiply by 12 to get 24? Answer 2. So if I multiply by 1 in the form 2 over 2, then I'll get a denominator that's 24. So this is just an intermediate stage. Let's work on the fraction 3/8. So we ask, what would I have to multiply by 8 to get 24? If I multiply 8 times 3, I get 24. So if I multiply by 1 in the form 3 over 3, then in the next step, we'll just multiply these two fractions, multiply the other two fractions, and then afterwards we'll add them. So 5 over 12 times 2 over 2 is 10 over 24. And we're going to add that to 3 over 8 times 3 over 3, which is 9 over 24. Hey, now that the denominators are the same, we have a common denominator. Now we can add the fractions. So the denominator of the sum is still 24, and the numerator, 10 plus 9, is 19. And in this case, 19 over 24 is already in lowest terms. Okay, let's do one more. Negative 23 over 27 plus 4 over 15. Since we're running low on time, I'll bypass this one for now. This is something you could work on for practice, for homework. But let's look at this next problem here down here on the left. We have negative 3/4 minus negative 4/5. First, let's remember what happens when you subtract a negative. So negative 3/4 minus negative 4/5 is equivalent to negative 3/4 plus 4/5. And the least common multiple of 4 and 5 is 20. 4 times 5 is 20, and 5 times 4 is 20. So we want to multiply 3/4 by 1 in the form 5 over 5. And we want to multiply 4/5 by 1 in the form 4 over 4. And then we get negative 15/20 plus 16/20. And then negative 15/20 plus 16/20 is positive 1/20. So what we did in the numerator, we had negative 15 plus 16 over 20. And negative 15 plus 16 is positive 1. So that's the result, 1/20. Okay, for a couple of minutes, we'll take a look at negative 23 over 27 plus 4/15. So how do we find a common denominator? Well, one way to do it is write down the prime factorizations of 27. The prime factors of 27, 3 times 3 times 3. And the prime factors of 15 are 3 times 5. So the least common multiple of 27 and 15, which will be the least common denominator, the least common multiple must have the factors in the prime factorizations. So this has 3 factors of 3, so the least common multiple has to have 3 factors of 3. For 15, 3 is already accounted for. We don't list another factor of 3 because one of those factors takes the place of that one. But this has a factor of 5, so 3 times 3 times 3 times 5, multiply that out, you get 135. Okay, so if we just multiply negative 23 over 27 by 5 over 5, we'll get the 135 denominator. And then if we multiply 4 over 15 by 1 in the form of 5 times 3 times 3, or I don't really want that, do I? So 9/9 is what I want. So the common denominator is 135. Negative 23 times 5 is negative 115. And then plus 4 times 9 over 135, I get plus 36 over 135. And then I'm going to get negative 79 over 135. You can check my arithmetic on that, but we're about out of time, so I do have to go to another classroom to be at another class at 9 o'clock. So that's all for today.